Here we go. All right, so 10.1. Yes, we're starting chapter 10 next. Chapter 10 in general is about gas laws. Right. So 10.1 starts off with characteristics of gases. Talks about phases of so basically like states of matter, phases, solid, liquid, gas. Another term for a gas is a vapor. So same type of idea. Gases are relatively significantly different from solids and liquids in multiple ways. You can compress gases. You can't really compress solids or liquids. Liquids you can a little, but very, very little. But you can compress gases. Gases will spread to occupy the full volume of their containers. When put under pressure, a gas's volume decreases. And gases always form homogeneous mixtures with other gases. Anybody remember what homogeneous means? Sort of, yeah. It's like you can't tell the difference between any of the parts. It all looks like one thing, right? It's not one thing, but it all looks like one thing. So now this next sentence here seems to contradict some of the stuff it said before, but because it says that gases occupy the full volume of the containers, gases only occupy a small fraction of the volume of their containers, which seems to be the opposite of this. But what they're talking about is the gas will expand to fill the whole container, but the actual gas molecules or atoms or whatever they are, the actual amount of volume that the actual molecule takes up is very, very small. There's a lot of empty space between them. So if you're talking about the gas as a substance, it fills the container. If you're talking about the actual gas molecules and the amount of volume they take up a very small amount of volume because there's a lot of empty space between all of them. Does that make sense? Okay. As a result, each molecule of gas behaves largely as though other molecules were absent. There's something called intermolecular forces. Intermolecular forces are ignored. Intermolecular forces are ignored. So without getting really, really into this, there are forces between molecules that attract them to each other. It's part of the reason why molecules in a solid stay together or molecules in a liquid stay next to each other. There's polarity, there's hydrogen bonding, there's all kinds of different things that attract molecules to each other. They work sort of like magnets in the sense of the closer together the molecules are, the stronger those intermolecular forces are. So if you pull molecules really far apart, those intermolecular forces don't work really well or at all. In a gas, the molecules are moving so far, they're so fast and they're so far apart that those attractive intermolecular forces are basically just ignored as if they're not there. Okay. Collisions between gas particles are perfectly elastic. That means that there's no loss of energy due to friction or things like that. So like right now, there's gas particles whizzing around this room around us, right? They're bouncing off the walls, bouncing off your eyeballs, everything. Now, when they hit something, they don't lose any energy with the collision. They don't slow down. Anybody know how, like, conceptually or like sort of like common sense wise, how we know that this is true? What would happen if gas particles did slow down or lose energy when they struck stuff? Yeah, good. They'd slow down, and then eventually, as they slow down, they would start coming together, right? And then they wouldn't be a gas anymore. So the very fact that substances can stay in gas form show us that when they have those collisions, they don't lose energy. Okay. All right. Page 394 has some common gas compounds. Okay. I'm assuming I put this in because at some point you might need it. I don't know why. Um, these are common compounds that are gases at room temperature. I believe that in maybe some of the questions, they might give you just the name and not the formula. So you can look it up on page 394, or you can just Google it too. That's fine. Doesn't really matter. But I think that's why I wrote that in the notes. Okay. All right. Questions on characteristics of gases stuff.